Hello dear viewers, a very warm welcome to our channel. It's very good to have you here. In this video we are going to have a look at all you need to know about valves. Think of an engine as a sophisticated air pump. To make power it needs to inhale, compress and then exhale. It has to inhale a precise amount of air-fuel mixture into the cylinders. This is done through these valves. And then it will compress, it will ignite it right in here in this combustion chamber. Ignition will take place. Once the air-fuel mixture is ignited, it has to exhale. Exhale is done through this valve. It has to remove the combusted air, the combusted exhaust gas. So the burned gas has to be removed. Engine valves are mechanical gates that control the breathing process. They open and close the passage between the cylinder and the intake, or the cylinder and the exhaust manifold. This precise timing is very critical for engine power, efficiency, and smoothness. So right here we have the passage. This is a port. This upper part is a port. As you can see, there is an exhaust port, for example. This exhaust port is connected to the cylinders through this exhaust valve. So exhaust gas will be removed from the cylinder and it will go through the exhaust manifold and then to the tailpipe. Similarly, right here we have an intake system. The blue line is an intake manifold which connects to this port, and once this intake valve opens, it will connect this cylinder to the intake manifold, allowing air-fuel mixture to be admitted into the cylinder. Now let's go ahead and have a look at the anatomy of the valve. When we look at the different parts of a valve, this is a very typical valve. When you look at the different parts, right here we have the head, right here the lower part, right here, this is the head. Well, the head is a disc part that seals against the valve seat. This is the one that seals, and this is the one that is exposed to the extreme temperature. When combustion is happening inside the cylinder, this cylinder head is exposed to extreme temperature and extreme pressure. So this part is called the valve head. This is a disc-looking part that seals the entire pressure against this valve seat. And then we have the valve face. Right here we have the valve face. This is the angled machined surface. This is a surface that creates the seal against the valve seat. Right here. This is called the valve face. And then comes the valve stem. This rod-like structure, the long, slender shaft that guides the valve up and down, and it is sliding inside the valve guide. Right here you see there are valve guides, so the stem is the one that is going to slide inside the valve guide, guiding the entire movement of the valve itself. And then we have the tip. Right here the tip is there. This is the one that is always in contact with the rocker arm. It is continuously being hammered for an overhead valve arrangement and for camshaft in-block type arrangement. This is the one that receives power, so it is hardened. This is the hardened end of the stem that rocker arms act on, or sometimes the cam follower repeatedly strikes. So this is strengthened. And finally we have the grooves. Right here there is a groove. Grooves are there to keep the springs in place. There are lockers to keep the spring return. The return spring are to be kept in here, and those grooves are there to lock them. Small notch at the end of the tip that hold the valve keepers or locks. So this is the groove. Every valve has a groove. This is the one where lockers are inserted, and the lockers are the one responsible for keeping the spring in place. Now when we look at the different types, basically there are two types. Intake valves are here. The function is to let fresh air-fuel mixture get into the cylinder, and they are typically larger in diameter than the exhaust valve. When you compare the size, usually intake valves are larger because suction into the cylinder is done by vacuum, and there is less time for air to be admitted, sucked into the cylinder. So in order to make sure that filling is done properly, we will have a usually larger valve head. So the one with a larger head, larger diameter is the intake valve. It will allow air-fuel mixture to be inhaled into the cylinder. Admittance of air-fuel mixture into the cylinder is done by the intake valve. Then, the other remaining valves are the exhaust valves. These are the ones that are used to remove exhaust gas after air-fuel mixture is combusted. The exhaust gas, which is under some residual pressure, will be removed when the exhaust valve opens. Right here we have exhaust valve. Depending on the configuration, there are either one exhaust valve or two exhaust valve. Depending on the configuration, there are engines with multiple intake, multiple exhaust valve. There are engines with two intake valve and one exhaust, two intake, two exhaust, one intake, one exhaust. It depends on the cylinder size and design. So the exhaust valves, they are usually smaller in design. When we look at the head size, they are usually smaller and they have to withstand extreme temperature. The back is exposed to exhaust gas that is rushing out of the cylinder. The front of the head is exposed to extreme combustion, which is going inside the combustion chamber. So they usually are exposed to extreme temperature and they have to withstand extremely large temperature. They are often made of more heat resistance alloy stem compared to the intake valve. Now, let's go ahead and see how the valves are operated. The valve train mechanism is there to open and close the valves at a precise time. For example, on an overhead valve arrangement, this is an overhead valve arrangement, we have rocker arms, we have push rods on the back side, there are push rods, and that push rod is to be activated by the camshaft. So the camshaft is located inside the engine block, and the camshaft pushes the lifter, which pushes the push rod and then pushes the rocker arm, which pivots to press down on the valve stem. As you can see right here, this is the push rod. This is the push rod. When push rod is moving up, it will act on this side of the rocker arm, pushing it up, and the rocker will pivot on this rocker shaft, and this end will go down, opening the exhaust valve. Same thing is true for the intake valve as well. So this is an overhead valve arrangement. Now there are some advantages to this configuration. The overhead valve arrangement will have some pros. For example, we will have compact cylinder head. The cylinder head can be made compact and simple design, and you can have good low-end torque when it comes to this type of arrangement. And there are some cons as well. Limited high RPM capability is there, and all these moving parts will make it a little bit noisier. So large moving parts are there. The push rods are there, the valve lifters are there, rocker arms are there. So all these moving parts are involved, so that will make it a little bit problematic when running the engine at extremely high RPM. The other configuration is where there is an overhead cam. The overhead cam is where the camshaft is not placed inside the engine block, rather camshaft is placed right on the cylinder head. Right here you can see the camshaft, and the camshaft will directly operate the valves without push rods and without no rocker arms involved. So this is a very simple design. Camshaft will be placed inside the cylinder head. Now there are different arrangements. There is a single overhead camshaft arrangement where all the valves are operated by a single camshaft. On some engines we will have double camshaft, one for exhaust and the other for intake as well. When we discuss about the valves, there are some terminologies to be understood in relation to operation of the valve. There is what is called, for example, the valve timing. Valve timing is the precise moment when valve opens and closes. There is an opening and closing of each valve. Now, if that is stated in relation to degrees of crankshaft, that is called valve timing. For example, you might say intake valve opens 30 degrees before TDC. If you say, for example, intake valve opens 15 degrees before TDC, that is timing the valve, the intake valve. Intake valve closes 55 degrees after BDC. If you say like that, that is describing the valve opening time in relation to the crankshaft. So valve timing is the precise moment when a valve opens and closes, measured in degrees of crankshaft rotation. The other is called valve lift. When these valves are opened, there is how far the valve opens off its seat. This is determined by shape and height of the camshaft cam lobe. So how far it travels when it is opening, that is called valve lift. And the duration for which it opens is called valve duration. How long the valve stays open. This is usually measured in crankshaft degree as well. So it could be open, for example, for 227 degrees. Intake will remain open for 227 degrees, if I say, for example. That is called valve duration. When it comes to advanced valve technologies, this configuration will have a fixed valve timing. It will have a fixed valve lift, and all that duration is fixed. But on advanced valve technologies, we have variable valve timing. You might have seen engines where it is written VVT or VTEC. This is where variable valve timing is involved. The system allows the engine to alter the valve timing. Sometimes it will also alter the valve lift. At low RPM, it optimizes for smoothness and torque by changing the valve timing. At high RPM, it changes to a more aggressive profile for maximum power. This is a game changer for modern engine technology. Modern engine efficiency is increased by changing the valve opening depending on the engine RPM. This is where variable valve timing is used. And on some multiple cylinder engines, on V8s, V6, there is also a cylinder deactivation. This uses complex valve tray system to completely stop opening the valves for specific cylinders during light load condition. For example, if your engine is a V8 engine and the engine is idling, there is no need of running the entire 8 cylinders. So it will deactivate 4 of the cylinders, for example, by simply preventing the valve from opening. So this is a very complex valve train system that will do cylinder deactivation by simply keeping the valves in a closed position. Now there are common problems associated to valves. For example, over time there is a possibility of valve bending, usually caused by a broken timing belt or a broken chain in an interference engine. The engine will not run and will require a major expensive engine overhaul if it is bent. If it is struck by the piston due to wrong timing, if the push rod is pushing it down, piston is hammering it from the lower side, that can cause bending of the valve. Valve bending is one problem. And in some extreme cases, burning of the valves, usually exhaust valve, typically an exhaust valve that has eroded from extreme heat. This is often due to lean fuel mixture, improper sealing, or this is caused by engine misfire, some kind of abnormal combustion, or improper valve clearance that prevent the valve from cooling off. That can be another problem. So you might face burned valves. Usually it is for exhaust valve. The other problem is worn out valve seals or valve guides. Valve seals, valve guides, they will wear out over time. Worn seals will allow oil to leak into the cylinder and leak into the combustion chamber, causing bluish smoke from the exhaust, especially during startup or during deceleration. Worn guides can cause excessive valve stem clearance, leading to oil consumption and ticking noise. So if there is a problem with the valve guide, the seat might not be sitting properly, and that might cause compression leak, that might cause oil leak into the cylinder as well. The other thing that can affect valves is when there is excessive carbon buildup. On direct injection engines especially, fuel doesn't wash over the back of the intake valve. So this intake valve on injections, some injections have fuel injections that is injected right in the vicinity of the back of the intake valve, which wash away any kind of carbon deposit. But in direct injection engines, there is no such thing, and that can allow oil and carbon to build up at the back of the piston, at the back of the valves, disrupting airflow and causing rough idling, and sometimes it can cause misfire as well. The other very crucial thing is valve clearance. The valve clearance is the gap between the rocker arm tip and the valve tip when the valve is fully closed and when the camshaft cam lobe is at the lowest position. If this clearance is very tight, the valve doesn't fully close, especially if the engine is hot. It doesn't fully close, causing loss of compression, power loss, and potentially it can lead to burning of the valve. Because the valve is not sitting properly, it will not conduct heat. That can cause burning of the valve, especially if it is on the exhaust. If it is extremely wide, if it is too loose, it can create loud ticking. As the rocker arm is hammering, that can cause noisy operation. So it will hurt the performance of the engine and it will become very noisy. Some engines require periodic valve clearance adjustment in order to eliminate this kind of problem. Maintenance is very easy. Regularly adjust the valve clearance. Make sure that it is always met, the specification is met. And on some hydraulically operated valve lifters, always change the engine oil. Regular oil change is very crucial. Clean oil is the lifeblood of the valve train, lubricating the camshaft, the cam lifters, and all the valve guides. And timing belt replacement is also very crucial. If the timing belt becomes damaged, single most important maintenance item to prevent catastrophic failure is the timing belt. If the timing belt snaps, then pistons will hit the valves. That will cause valve breakage, stem bending, piston breakage as well. So these are some of the things that you need to know when it comes to valves. Engine valves are very, very, very crucial. They are deceptively simple components that perform one of the most critical jobs: inhaling and exhaling. Their precise high-speed operation is very crucial. Then it has to be well maintained. It will directly affect engine efficiency, engine power, and engine performance as well. So understanding their function and the systems that control them is very crucial. Understanding how an engine truly operates. So these are some of the things that you need to know regarding the valve train mechanism. This is how they open. Look, right here, for example, exhaust is opening right here, followed by intake opening. This is how the valves are operated, and you can see the valve train mechanism activating them by valve lifters, push rods, and rocker arms. All this based on the engine timing. Well, dear viewers, that is all we have for you regarding the valve train mechanism and all you need to know about valves and their problems and their operation. If you find this video helpful and if you like what has been presented, please do smash the like button. If you are new to this channel, consider subscribing, turn on notifications so that you will be the first to get notified whenever we come up with another video. Until then, stay safe.